Hey guys, Mrs. Traver here. We're going to work through our notes on section 1.7, which talks about completing the square. So let's jump right into it. First, I want to set us up with an example that'll show us why it's important to be able to complete the square. Let's say I had a situation like this and I was looking to factor it. This one, we're looking for factors of 16 that add to -8. I would need to use -4 and -4. So I would have factored to have x minus 4, which anything times itself is something squared. So this could be rewritten as quantity x minus 4 squared. So I wanted to mention that this is called a perfect square trinomial. So perfect square because it worked out perfectly, and trinomial because tri meaning it started with 3 terms. Nomial means terms. So perfect square trinomial. What we're going to end up doing is starting with things that are not perfect squares and forcing them to become perfect squares by completing it with the last number it needs. I'll show you what I mean by that. So here's our first example. Say I had x squared plus 14x plus c. And normally they're written with a number in the C spot. But what I want to do is I want to find the perfect C so that I could make this be a perfect square trinomial. So I'm looking for a number that multiplies to get C and adds to get 14, and it's the same number. So I can end up having x plus or minus it quantity squared. So you might be able to guess you will need to use a 7, because 7 is the only number that adds to itself to make a 4. So I would have needed 7 plus 7. I would have needed 7 and 7. So that's the number we're going to need. But what would our C have been? If you think about the FOIL out, the L term, the last times the last, would have given us 49. So our C here, our perfect C term, I'll call it, in this situation is going to be 49. But how do I find that in general? Let's see what we actually did. We did 14 divided by 2 is 7, and then from 7 to 49 we squared it. So that's the method. Our perfect C term is b divided by 2, this second number divided by 2, quantity squared. So that's exactly what we did. We did 14 divided by 2 was 7, and then we squared it to get 49. So if we had a 49 in this spot, then that would have made it a perfect square. Let's do another one. All right, let's look at these two examples. So if I was looking for the perfect C term in each of these, I would have done -28 divided by 2, quantity squared. -28 divided by 2 is -14. Quantity squared is 196. Notice that my negative was inside the square root. Matter of fact, our perfect C term, because the last thing we did is square it, it will never turn out to be positive because nothing squared is a positive. Let's look at the next one. So I've got 11 as my B. So 11 divided by 2, quantity squared. I could make this 5.5 right now. I'm just going to leave it as 11 halves and think about this as 11 halves times 11 halves. So I've got 11 squared is 121. And 2 squared is 4. So we can just leave it as 121 over 4. Let's try these ones where we actually solve for the terms. All right, so it's kind of clued off to us that we're going to be solving now because I have the equals 0 with it. So let's see. I already have something in my C spot, but I know right now this is unfactorable. No two factors of 4 would add to become a 6. 4 just gives us a 4 and a 1 or a 2 and a 2. And I can't make a 6 out of that with addition or subtraction. So right now this is unfactorable. Let's figure out what we want our C to be, and let's move the 4 out of the way so we have room for the C that I want to put in there. So let's move our 4 to the other side and give ourselves a spot for that C to go. We want our perfect C to be b over 2 quantity squared. So 6 divided by 2 is 3. 3 squared is 9. So I wanted this to be a 9. That'll make it work out nicely. But here's the deal. I can't just add 9 to one side. I need to do everything to both sides with equations to make it still equal. So if I add 9 to the left, I also have to add 9 to the right. Now, my left side, it'll work out to be two numbers that multiply to 9 and add to 6 is going to be 3. So I would have had x plus 3 times x plus 3, or x plus 3 quantity squared. All right, on my right, I now have 5. And from here on out, we can solve by using square roots. So since I have my quantity squared by itself, I'm able to take the square root of both sides. And don't forget your plus or minus when you square root a number. So square root of something squared, it goes away. I've got x plus 3 on the left. On the right, I have plus or minus root 5. I'm done when I have x by itself, so I still need to move this 3 over. I'm going to move it over to the front spot. That way I have x equals negative 3 plus or minus root 5. So there's my final answer. If I could have simplified my square root right now, I will, but I can't do anything with 5, so I'm all done there. Let's do another one. All right, so on this one, let's do the same steps again. Move your 4 to the other side so you have room for the term that you'd like to put in. The term we want to put in is negative 12 divided by 2 is negative 6. Negative 6 quantity squared. Let's look through this one. So check your work with mine. Hopefully it looked all right. The number that I used was 36. And then I was able to square root and simplify my root at the end. So check my work there and see if it looks good with yours. All right, hopefully that one looked good. Here's my last one I want to show you. This one's a little bit different because the a value out front is not 1. Let's first, like we did before, try to get our C spot open for us. So let's move the 15 to the other side. And now, because what I have left over here, the a is not 1, let's factor a 5 out of the left. I'm aware that we could have also factored out, oops, that should be a 2. I'm aware we could have also factored out an x, but I don't want to because then I no longer have bx to deal with. So, all right, let's see. What's the fancy C term that I want to use? It is 2 divided by 2, which is 1, and 1 squared is 1. So if I add 1 to the left, let's see. We need to pause here because normally we would say plus 1 on the right. But notice, because this is really a 5, if I would have distributed the 5 back in, I really added a 5 to the left. So we need to also add a 5 to the right. So be careful right there. Because if we had factored something out, we need to multiply it back in before I add to the other side. So watch what I did there and make sure you're all right. From here, though, I can finish off. Let's see, we've got 5 times the quantity. This would have been x plus 1 quantity squared equals 20. Get your squared term by itself before you move on. So I want to divide both sides by 5. And now I can square both sides. So I've got x plus 1 equals plus or minus the square root of 4. The square root of 4 is 2, so I've got x plus 1 equals plus or minus 2. Subtract 1 from both sides, so x equals negative 1 plus or minus 2. Negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. So my final answer here for x is that x equals 1 or negative 3. This one was a little bit tricky. So again, if I can make note, because we had to factor out to get our a to be 1, we had to watch out for when I put in my perfect square c, that I looked at what would c be with my factored out coefficient there. So that's the term I added to the other side. If you don't add the right term to the right side, it's not going to work out to be the correct root. Hopefully this helped out. Our next sections are going to be on the discriminant and the quadratic formula. I will see you then.